everybody. Welcome to week 1 of our geometry and measurement course. I'm really excited to have you guys in this class. And every week I will be doing a video to kind of outline the general topics for the week and to give you some perspective on how to teach the various topics of that week. So this week's focus is all about shapes. And you'll have 3 different content assignments this week. So you have case studies, video projects, and homework. And you also have some orientation assignments that you'll finish towards the beginning of the week to just get accustomed to how the course works and stuff like that. But every week from here on out, you'll always have a case study assignment, a video project, and a homework assignment. So in this week's case studies, you're going to be reading through some examples of how students identify the difference between like 2-dimensional shapes and 3-dimensional shapes, as well as how they decompose those shapes into their component parts, and how to describe those components as well. So those are kind of the themes you'll see showing up in the case studies. And then for the video projects, you guys will make videos explaining how to categorize various shapes. Well, most of you will. So 4 of the topics are about categorizing shapes, and then the last topic is cross sections. So it depends on which project you were assigned to. And in our orientation meeting, I'll go into more detail of what those videos should look like. But these are the topics for the video projects this week. And then your homework will kind of have 3 different topics. So the first one is that you'll read through some other case studies, which are different than the case studies that you're doing for the case study assignment. And you're going to identify what level of the Van Hiele theory the students in that case study are at. So I'm going to talk about the Van Hiele theory in just a second, but that's the first part of your homework. Then the second part of the homework is to practice using the vocabulary word for categorizing triangles and quadrilaterals. So the second page will be all about categorizing shapes and finding the relationships between those shapes. And then the last part is to find 2-dimensional cross sections of 3-dimensional objects. So this is an outline of the homework or the assignments that you guys will be completing this week. And in this video, I'm going to go through some of the topics that you'll need to know for these assignments. Now, keep in mind that on the homework, a lot of the things that you'll see on the homework will be review of stuff that's in 2010 and 2020. So I will give you a quick overview in the weekly instructional videos, but if it's been a long time since you've learned the topic, you may need to do some research online and find other videos that go into more depth about how to solve the problems, depending on your level of comfortability with those topics. So I'm hoping that all of the topics on the homework should be pretty familiar, especially if you've taught some of the upper grades, like 4th and 5th grade. But it is possible that maybe you just forgot some of it, and that's totally fine. And you're welcome to research those topics online if you need to complete the homeworks. So for the instructional video this week, I'm going to go through the Van Hiele theory and the different levels of learning. And then I'm also going to talk about how you would teach the decomposition of shapes. So let's start off with the Van Hiele theory. So this theory is basically a kind of like a structure of how children and people learn geometry. So there's 5 different levels, which are leveled from 0 up to 4. And most of your students will stay within level 0 up to 2. Because level 3 usually happens more in high school and early college. And level 4 is mostly only done by like mathematicians who like are math majors or go to grad school for mathematics. That's kind of what level 4 looks like. So let's start off with level 0. So students at level 0 on the Van Hiele theory are looking at shapes holistically. So a student that might be at level 0 would look at these shapes and say that they're triangles, and they would look at these shapes and say they're not triangles. Even though in reality, with the way that we've defined triangles, all of these shapes are triangles and these 2 are not triangles. And so when a student is at this level, they're not looking at the different parts of the shape, they're just looking at the shape as a whole. So a student who identifies these as being triangles is basically thinking of this as a holistic shape. And then it's like, oh, well, this shape kind of looks like what I think a triangle is. And so does this one. Even though those are not actually triangles because the edge is curved. A student who looks at it, when they look at it holistically, they're like, yeah, that looks like what a triangle should look like. But when they're presented with a triangle like this, they say, oh, that's not a triangle because it's too long and skinny. And triangles don't look like that. Triangles have to look more like this in order to be a triangle. Um, and so at this level, students will often describe the meaning of what a shape is in terms of objects in their world. So they might say something like, a triangle is like a tent. So rather than saying a triangle is a shape that has three sides, they'll say a triangle is like a tent, or a rectangle is like a door. And they describe the objects in terms of the shape as a whole versus like the individual parts of the shape. So in kindergarten and first grade, a lot of students are going to be at this level because this is kind of the beginning level of understanding geometry, is just recognizing basic shapes. But if you want to help your kindergarten students move to the next level, you can help them start identifying the individual parts of the shapes, because the next level is the analysis step. And students at this level will identify attributes of shapes, like how many sides does it have? Are the sides straight? What are the angles? Are they like, do you have 4 angles or do you have 3 angles? Are they right angles or are they different types of angles? And so students at this level would be able to identify that these 2 shapes are squares and these 2 shapes are not squares. And their reasoning behind this would be because their reasoning would be based on the components of the shape. So they would say, well, this is a square because all the sides are the same length and all of the angles are right angle. This is also a square because all the sides are the same length and the angles are right angles. And so they're looking at the parts of the shape and using the parts of the shape to identify the shape. And so they'd be able to say these ones are not squares because even though all the sides are the same length, these angles are not right angles. Or these ones are right angles, but the sides are different lengths. And so that's what makes these not squares. And students at level 1 would be able to articulate the difference between these 2 sets of shapes. In comparison, a student at level 0 might say that this is not a square because it doesn't look like a square. Like that would be their reasoning, because they're like, oh, well, it doesn't look like what my brain thinks a square looks like. And they might say that this is a square, depending on how they think about it. And it can be interesting to have conversations with your students about why they think that. Because if a student says this is not a square because it doesn't look like a square, some students might say, but yeah, it does look like a square because if you turn it sideways, then it does look like a square. So they're still operating at level 0 because they're identifying a square by what it looks like. But the student who says that you could turn it sideways is understanding that like essentially what makes a shape congruent, that you can rotate a shape and it's still the same shape even if it's rotated a different way. And some students will understand that and some won't, but you can have discussions about it in class, which will help them start to develop those concepts. um, so that's level 1, is where students identify shapes based on their different components, like the number of sides, how long the sides are, their angles, and so on. And then level 2 often happens in the upper grades, like 4th and 5th grade and 6th grade, because students at this level will understand the relationships between different categories of shapes. So at level 1, they can take the different parts of the shape to define what the shape is. But at level 2, they'll be able to compare squares and rectangles and realize that all squares are also rectangles, because rectangles have 4 sides that are straight and all of the angles are right angles. And squares have all of those characteristics with the extra characteristic that you also have to have all sides the same length. And so at level 2, students start to make those types of connections about the relationships between different shapes. So that's level 2. And then level 3, like I mentioned, usually happens in high school or early college. And this is where students are understanding the notions of mathematical postulates and can write formal proofs. So this stage of geometry is understanding what all the definitions are, being able to tell the relationship between shapes, but then you can prove the statements about the shapes using a logical process or logical reasoning. So that's level 3. And most of your students in elementary school will not be at this level. If they are, they'll probably be in a gifted program. So you won't ever be teaching students at this level. But this is the level that you guys will be operating at in this class as you guys make your videos about why certain formulas work or why certain concepts work the way they do. So this is the level that you guys will be operating at. And then level 4 is axiomatics. And like I mentioned a little earlier, basically the only people who actually get to this level of geometry are usually like math majors or people who are going to grad school for math. Because at this level, you scrutinize the axioms and postulates of geometry and you explore what would happen if you didn't have those baseline axioms. So like, for example, most of the geometry you've probably ever done is in Euclidean space. So a two-dimensional Euclidean space is basically like a flat space or like a flat surface. And you can also have three-dimensional Euclidean space where you also have like a depth to it as well. But basically Euclidean space is all based on right angles and like I kind of think of it as like rectangular space because like everything is mapped out in like a rectangular grid versus non-Euclidean geometry, which is something that math majors will explore, is what happens if you work in a space that's spherical instead of flat or rectangular. So like in Euclidean space, a triangle will look like it has straight sides because it's laying on a flat surface. But in spherical geometry, there is no such thing as like a flat surface because the space you're working in is spherical. And so you might have parallels where a triangle looks like this, even though if you were thinking about it in Euclidean space, it wouldn't be classified as a triangle because it has curved edges. And there's other things that change as well when you change the axioms of what type of space you're working in. So it's okay if that not all of that made sense. This is much more advanced than we will get to in our class. But those are kind of the 5 levels of the Van Hyle theory. So your students will usually stay between level 0 and level 2. And younger grades will tend to be in level 0, maybe level 1. Middle grades will be more in level 1, and level 2 is more like 4th and 5th grade and 6th grade. And you guys will be operating at level 3 when you guys make your videos for the video projects. So that's the basic outline of Van Hyle's theory. And the purpose of understanding Van Hyle's theory is to be able to identify where your students are at so that you can design the right activities to help them move to the next level. So if you were teaching kindergarten and your students were identifying shapes based on their overall appearance, like saying a rectangle is like a door or a triangle is like a tent, the activities that you would plan would be to help them move into level 1 where they're looking at different components of the shape. So you might say like, okay, so a rectangle is like a door, but how many edges of the door are there? Or how many sides does a rectangle have? And you can get them to start thinking about, oh, rectangles are things that have 4 sides versus triangles have 3 sides. And that's the thing that's different between them. And so there's lots of different activities you could do to help students make that jump. And then once your students are at level 1, like if you're teaching, um, like third grade or something, most of your students will probably be at level 1 by then. And then you can start doing activities that will help them move to level 2. So that's kind of the purpose of why we're talking about the Van Hiele theory here. And one of the key concepts in geometry in general is being able to take shapes and decompose them into their parts, and also being able to categorize those shapes. So that's again working at like level 1 and level 2 of the Van Hiele theory, because level 1 is decomposing them into their parts. Level 2 is being able to categorize them and compare them to other shapes. So one of the ways that we categorize shapes is by their dimension. So a two-dimensional shape is kind of like a flat shape. And the reason we call it two-dimensional is because there's two different directions that you could measure this shape. You could measure the width of the shape and you could measure the height of the shape. And I mean, technically you can measure like diagonal distances as well, but there's two perpendicular distances that you can measure on a flat shape. On a three-dimensional shape, there's three distances because you can measure the width, you can measure the height, and you can measure how deep the shape is. And so that's why it's called three-dimensional. And these two types of shapes are very different in the way that students experience them, because two-dimensional shapes are ones that like you could cut out on a piece of paper and they are flat shapes, versus a three-dimensional shape can really only accurately be conveyed with a three-dimensional object, like a pop can or a ball or a pyramid or something like that. So this is the first key, I guess you could say, categorization of shapes, is the difference between two-dimensional shapes and three-dimensional shapes. And then within these two types, there's lots of different ways that you can decompose the shapes and categorize them. So you can have open and closed shapes, convex and concave shapes. You can look at the number of sides or how long the sides are. You can look at whether those sides are parallel or perpendicular. You can look at the number of angles. You can look at the measurements of those angles. You can look at the symmetry of the shapes or the regularity, which basically is like, are all of the sides the same length or are they not? So those are all different ways that you can categorize two-dimensional shapes. And then when you're looking at three-dimensional shapes, there's other things that you can look at. So you can look at the faces of the shape, which are like the two-dimensional surfaces on the sides of the shape. You can look at edges, which is where the faces meet. So edges are kind of like a line where the two edges meet. And then vertices are the points where the edges meet. So you can decompose three-dimensional shapes in that way. And you can also look at things like cross sections, which we'll talk about in just a minute. But there's lots of different ways that you can kind of break down a shape into its component parts. And it's important when you're working in these younger grades to really help students understand what all of the different parts of shapes are. Because for us as adults, it's really easy to be like, oh, like a triangle is a triangle. And this is a triangle. A triangle has three sides. But when students are first learning about it, the way they conceptually understand it goes through that Van Hiele theory, where they first kind of think about a triangle as just like one object that looks like other objects they see in their life, like a tent. And then they have to explore triangles in more depth to really understand on a conceptual level that a triangle is actually a shape that has three straight sides that is closed. Like that's another level of understanding that is actually quite distinct from level 0. And so, one of the ways that you can help your students develop this really conceptual understanding of the shapes is to have mathematical discussions that allow the students to articulate their thoughts. So, let's say, for example, that you wanted students to learn about these two three-dimensional shapes. So, the names for these two shapes are a cylinder and a sphere. So one way you could teach the lesson is you could say, all right, class, we're going to learn about three-dimensional shapes. this shape is a cylinder. Everyone repeat cylinder. The class repeats it. And then you say, this shape is a sphere. Everyone repeat this. And then you could do some kind of activity where they have to like sort different shapes into cylinders and spheres or whatever. However, this method of teaching is really only teaching them the vocabulary words for the shapes, and it's not really helping them explore the shapes at all. So, an alternative way of teaching the same concept is you could show the students these two three-dimensional shapes, and you would want to actually have physical models of it. So, like a wooden block that's a cylinder and a wooden block that's a sphere. And you'd say, okay, we have these two shapes here, and I want you guys to describe in your own words what these shapes are. And this is a very different type of activity because now you're going to facilitate a mathematical discussion where the students have to articulate what their thoughts are. So you might get some students who describe the cylinder and they say, well, that's a can. Like that's like a can, like a can of soup. Or, they might have some other physical object in their life that looks like a cylinder. And then they might say, this one is like a ball. And when students respond in that way, you can mentally think and say, okay, these students are experiencing this shape as at level 0 on the Van Hyle theory because they're not identifying the component parts of the shape. They're just looking at the shape as a whole and they're comparing it to the things that they know of that also look like that shape. And so you'd say, okay, those students are at level 0. And so in order to help them move to level 1 in their understanding of three-dimensional shapes, I need to help them start looking at the different components of the shape. But this could come out very naturally with the design of the way that you ask the question, because other students might say something like, it's a circle. Now, technically, that is very inaccurate because a circle is a two-dimensional shape, and these shapes are three-dimensional. But students who say that it's a circle are using the best language that they have to describe what these shapes are. And it's actually a more advanced way of thinking geometrically than those people who say it's like a ball or like a can because they're looking at the components of the shape. And one way you could draw this out in the conversation is you could say, okay, so you're saying that this one is a circle and this one is, but they both are very different shapes. Like, how can they both be a circle if they look so different? And the students will be like, oh, yeah, like, well, I know they're both circular, but like they are different too. So, how am I going to describe this? And they're going to have to refine the way that they're describing it. And so they might say something like, oh, well, like this one is a rectangle circle, and this one is a circle. Now, again, this is not geometrically accurate vocabulary, but it's communicating a really key concept that the students are intuitively understanding. So at this point in the discussion, you don't want to shut them down and say, no, like a circle is a two-dimensional shape. Like this is not a rectangular circle because both rectangles and circles are two-dimensional and this is three-dimensional. You don't want to shut it down by introducing that technicality yet. You want to draw it out of what they mean by that. Because ultimately, a student who is saying that a cylinder is a rectangular circle is communicating that they're seeing the shape in terms of its cross sections. Because if you were to cut a cylinder right here and like cut it down that part right there, it would make a rectangular shape. Like if you cut the cylinder and looked at the surface of where you cut, that would be a rectangle. And if you cut it this way, where you cut it along that spot, and you looked at that surface of where you cut, that would be a circle. And this is a key concept in geometry that's called cross sections. Because a cross section is a two-dimensional component of a three-dimensional object. So the idea of a cross section is you take a two-dimensional object, a three-dimensional object, and you cut it. And the surface that's created by that cut is a two-dimensional space that's called the or one of the cross sections of that shape. And depending on which way you cut it, you will end up with different cross sections. Because if I were to cut my pyramid like right from the tip all the way down, well, that cross section would look like a triangle, and it would be a two-dimensional triangle on that surface. But if I were to cut it, let's say like right here, and just cut straight down, in that case, I would have a trapezoid as my cross section. So depending on which way you cut the shape, you could end up with a square or a triangle or a trapezoid. And on your homework, you guys are going to be exploring the different possible types of cross sections that you can have. But going back to this discussion that you'd be having with your students, when a student says that this is a rectangular circle or a rectangle circle, what they're really communicating is an intuitive understanding that a cylinder would have rectangles and circles as cross sections versus the sphere, which they called a circle, is like the only type of cross section you could have would be circles. Because even if you like cut the sphere right here, that cross section would be a circle. If you cut the sphere across its equator, the cross section would still be a circle. And it doesn't matter which way you cut it, it's always going to have a circle as its cross section. And so that would be something that you would want to draw out in the conversation. And you can have quite an in-depth mathematical discussion about that before they even know the names of these shapes, because you still haven't told them that this is called a cylinder. This is called a sphere. What you did was you had them define how they would describe it, and then you draw out the different parts of the shape as part of that conversation. And so that could be one way that your students could see it. Another way that a student could see this exact same thing, we had, so kind of to summarize, you have the students who said it looks like a can or it looks like a ball. Then you have the students who said that it was a circle and refined their answer to say that it's a rectangle circle or a circle. You might also have a student who says that a cylinder is like a circle with a whole bunch of circles stacked on top of each other. And in that case, they're actually understanding it's like it's technically it formally shows up in calculus, but it's the idea of having two-dimensional shapes with an infinitesimally small depth that are all stacked on top of each other. And that's related to the idea of integrals in calculus. And so they might say that a sphere is a whole bunch of circles of the same size that are all stacked up, versus a sphere is a bunch of circles of different sizes that are all stacked up. Because the top of the sphere just has a little circle, and then as you go down through the sphere, you get bigger and bigger circles until you get to the equator of the sphere. I actually don't know if that's the formal name for it, but that's the way I think about it. That's going to be your biggest circle, and then you get down to smaller and smaller circles until you get to the bottom. And so that would be even another way of looking at the different components of this. Kind of looking at it as like, what two-dimensional shapes would you have to stack on top of each other to make this shape three-dimensional? Another way that you could also look at the sphere is that it's like a circle that's been rotated. So if you had a circle, and like imagine this like a piece of paper, and you put like a rod through the middle, and then you twisted that rod and like rotated it around that rod, that would create a sphere shape in like the rotation of it. Like if you spun it really fast, so you couldn't, you know how like when you spin it really fast, it makes it look like it's like one full shape kind of. That's another way that you could also interpret a sphere. And your students may come up with all of these different ways of interpreting it, even though they don't know that the name for this three-dimensional shape is a sphere. And so after you've had all of these conversations, then you can share with them the vocabulary of, this was really great. We learned a lot about these shapes. Just so you know, these are the names for these three-dimensional shapes. So what you guys called a rectangle circle is actually called a cylinder, because rectangles are two-dimensional and circles are also two-dimensional. And you guys are right that we have two-dimensional cross sections. So we have a rectangular cross section and we have a circular cross section. but the shape as a whole is called a cylinder. And then you can do the same thing for a circle. And by introducing vocabulary in this way, it, for one thing, helps them remember the vocabulary better because they've fully experienced the shape before they learn the name of it. And by them coming up with their own names for it, like a rectangle circle and a circle, it helps them remember the different components of the shape and explore those. So this is an example of how you could lead a lesson that leads students to understand the components of a shape versus just knowing what the shape is. So that's a three-dimensional object that you could do, but you can also decompose two-dimensional objects. So one way you could decompose this two-dimensional shape is you could break it down into the number of sides it has. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. And so this would be called a decagon. And that name, decagon, is basically a way of communicating how many sides the shape has. And so that could be one lesson about decomposing two-dimensional shapes. Another way you could decompose this shape, though, is you could look at the two-dimensional shapes that it's composed of. So you could say, I have a rectangle right here. I have another rectangle right here. And I have another rectangle right here. And so this shape is kind of like three rectangles of different sizes that are all stuck together. And this is a different way of decomposing the shape that is really helpful when you're trying to teach area. So remember, with shapes, there's always lots of different ways you can decompose it. The side length one was more of a one-dimensional decomposition because I was just looking at the different sides and how many there were. But you can have a two-dimensional decomposition where you're looking at how much flat space is inside the shape and what simpler shapes compose that shape. And there's lots of other ways that you can also do it because you could look at angles. You could look at what would be another two-dimensional one. You could look at whether the sides are parallel or perpendicular to each other. So there's always lots of different ways you can look at shapes. And depending on what the topic is and what you want to focus on, you can design activities to help the students explore shapes in more detail beyond just knowing the names of them or the various features, but really being able to understand conceptually what it is that makes that shape what it is. So I hope that was helpful. So just as a reminder, this week, your case studies are going to give you some examples of different classes and different students that have explored the idea of shape. Your video projects are where you guys are going to explain how you categorize different shapes. Or for those of you with the cross-section one, you'll be explaining what a cross-section is and what that means. And then on your homework, you're going to be practicing identifying the Van Hiele theory, identifying different types of triangles and quadrilaterals, and also looking at cross-sections. So if you have any questions, let me know, and I hope that you have a great day.